Hi, this is Scott Moore of Scott Moore Consulting. You can find me on the internet at scottmoore.consulting in your browser. My handle on Twitter is LoadTester, and this YouTube channel. Please subscribe to it so you can see all the new videos that I post, as well as register for upcoming giveaways.
This video accompanies a LinkedIn article that I wrote called Performance Testing HTTP2 Web Applications. And this video is intended to take you into a little more detail about how I configured the server settings, set up the website, and used Loadrunner 12.53 to test against an H2 web app. If you want to find out more information about HTTP2 in general, I wrote an article earlier on LinkedIn called HTTP2 is Exciting for Performance Engineers. And there I take you through the background of HTTP2, how we got to where we are today, the differences between 1.1 and 2. So there's a lot of links there and references that you can use to get a lot of background. I want to mention a couple of websites that we did use to configure this test server, and to just give you some brief background. We started with an Ubuntu operating system doing version 14.04, and it comes with Nginx already loaded on it for the web server. So we used this article from Left Shift to upgrade Nginx to the latest version so that it would support HTTP2. We also set up server blocks and used DigitalOcean's website to kind of set up our website on Ubuntu. We also used DigitalOcean to teach us how to create our own SSL certificate because H2 traffic is, by default, it goes over a secure connection. Finally, we set up HTTP2 support in Ubuntu. Notice that this is an article relating to version 16 of the OS. That's going to turn out to be important as we move through this because we did find some issues between 14 and 16 concerning H2 support. I also want to mention Scott Helm's website. This blog shows how to set up a custom monitor to look at the H2 traffic and the version of the ciphers and the TLS version that's being used on your site should you choose to move over to H2, and I thought it was worth mentioning. HP Software has released Loadrunner 12.53, and it does have H2 support in it. And this article that was released not too long ago goes through the main features of HTTP2 and how to set up VUGen to record against a site, and I highly recommend this. These links are all on the LinkedIn article that I wrote.
So just briefly, I want to cover a couple of the configuration settings just so that you can see what they are. I'm going to go into the Nginx folder. You can see we have a nginx.conf file, so I'm going to just page through that configuration file so that you can see that. Alright, as I scroll up here, you'll see that we have server name hash bucket size of 64 according to the instructional instructional page that I saw. You should have this turned on, so I turned that on. I also had to add this preferred ciphers, so where you see SSL ciphers I had to manually add this line in there as well. And then finally I added this custom log section which was based on the blog article that I mentioned earlier, where we're doing a custom log to tell us how much traffic is being used. Everything else in here is pretty much standard. Anything that's got a hash mark on it is obviously commented out. You'll see that I have a website in var www called http2test.com, and that may be a real domain out there, but I'm actually not using it. I'm actually mapping that manually in my own host file to point to the IP address, which is temporary, and by the time you see this video, probably this machine won't even exist. So even if that's a real domain out there, I'm not using that as a public domain. So if you go to that site and there's something there, it's not going to be what you see in this video. So if I go into that directory, you'll see that I've got all of my HTML in there. So I've got a directory of my images, I've got my index.html, my index debug. That's the only thing that I have on this server serving up content. So now let's go look at the server block. You'll see that I have a directory in here called sites available. So let's go into sites available. And you'll see that there are two. One's called default, one's called HTTP2test.com. That's the one, HTTP2test.com is the one I have made the default, so that when you go to this IP address or server name, it takes you directly to HTTP2test.com. And this is the server block for it. Let's just page through it. So notice that I'm listening on both port 80 and 443, which means you could get to this page without going through SSL or TLS, and it will pull back the page. And you could actually compare how much overhead TLS would add, which is going to be very minimal in this case. In the 443 where it says SSL configuration, so we had to turn that on. Notice that where it says listen 443 SSL HTTP2, that HTTP2 is the only real difference between setting up Nginx for traditional TSL for 1.1 and 2.0. So we had to add that, and then we did have to create a custom certificate, and I've listed where that certificate is actually at here, and this is the custom key that I had to create for it. So in those articles at the beginning of this video where I mentioned having to create those things, DigitalOcean was very helpful in showing how to do that. So it's very easy to do, just follow the instructions. This certificate that we're generating is obviously not really valid because it's not going to a real certificate authority that would say, yes, we know who this person is, and it's not a hacker trying to get to you. But Chrome doesn't know that. So we're basically creating an SSL certificate just so that we can prove out this demo. And Chrome is going to complain about that when we first go to the site, and it's going to say, hold on a second, this doesn't seem safe because the certificate isn't legitimate, but obviously we know that we can get in to the site without any problem. So that's what we're looking at here. That's really the crux of this, is creating a certificate, creating a server block, and then creating your own page, setting up Nginx to accept HTTP2 traffic. And so that's the only thing. So it's the same web site that we created for version 1. And next we're going to see how that actually now looks in your browser and compare the two. Okay, let's look at the behavior of HTTP 1.1 and version 2 just from the developer tools in Chrome. It will tell us a lot. If we open up the developer tools and you go to the network tab, you can refresh the page, and if you do not have this protocol column, you can basically right click and make sure that you have check marked that. So what you're seeing here is 300 page requests of the images, because there's 300 images, and another request for the text file. Each one of these went through the HTTP 1.1 protocol, and you can see the various sizes of the images and how long it took to download each one of these. And if we wanted to refresh the page, we're again making 301 requests. However, we've already cached these images, so we're only transferring 54.1. However, it still took 3.82 seconds to download each of these. So what that's telling me is that even though we have a lot of cached images, the 300 requests are very expensive with 1.1. Let's do this same test with HTTP2. Now, this is a totally different server. I've switched from this tab to this tab. And now I'm going to the server that is displaying version 2 information. I'm going to hit refresh. Notice how much quicker this went through. So in this case, even though we transferred 450K, we still made 301 requests. It was through a single TLS connection that was much faster than all of the other connections, and it was 1.64 seconds uncached. So to me, that's significant. And also, you can see the sizes and the times of each one. Now let's see what happens on that subsequent request. Okay, this is interesting because for HTTP1, it was 54.1 KB, 27 KB for version 2. And the finish time was even less. It was 1.28 seconds. So why would this, if the only thing that was supposedly cached was these images, how come that was smaller amount? How come these sizes are smaller as well? The reason why is because we have header compression built into HTTP version 2 and up to a 50% compression factor. So it looks like that's about what we're getting here. So because the images are already cached, we don't have to pull that down, and then the headers are then further compressed by 50%, where we don't need to pull down all of that information for every request like we do with version 1.1. We're saving all of that, and it's much less expensive to pull back. So if, as you can see, when we're dealing with lots of images, and of course everybody's going to have to deal with headers from this point forward, the savings that you get from a site like this is going to be very beneficial. So HTTP2, from a performance engineer standpoint, very exciting. So I just wanted to show you here, just with what you could do without even any kind of a testing tool, you can see the benefit of H2, and you can prove out when it's being used and the differences. Now, just so that you can see the debug factor here, I wanted you to see what it shows in the page. So if I go to clean out the cache, all right. So there you can see the developer tool says 4.21 seconds, and in my calculation the page loading time is 4.138, and probably this additional amount is the actual JavaScript that's running. And then we make an additional request. Now again, we're only taking 55.6 KB, but it's taking 3.7 seconds to do that. This is the JavaScript that writes to the console, so it's the same information here. All right, let's do the same thing here. Again, 1.6 seconds for 451K. Hit the refresh. 1.1. So, again, HTTP version 2 rules the day. And so that's our first indication that we're going to be dealing with much faster pages.
Okay, now I want to just show you the HTML itself, what I was actually testing on the page, and then we're going to go into Loadrunner and see how I scripted and tested against this site. So we have a lot of images here that most of the time are not going to be used. It was some code that I put in after we started testing against this because Chrome is going to be looking for an initial icon for the browser page itself. So I just put these in here, all these pictures that you see here, but maybe only one or two of them would be used. But the fave icon is something that the browser would be looking for. So we add that a little bit later. However, this folder for images is important because these are all the images that make up the total 300 requests that we were talking about. So I use just an image splitter program to split up a large PNG into smaller PNGs and be able to just test that as individual image requests. So the HTML, I'm just going to open it up in Notepad and show you it's a very simple web page, very simple HTML. Again, these are only going to be used depending on the device that you use. And then here's the main code, which is just what you see on the page text-wise, and then here are all the references to all the images as they load into a big table with the rows and columns. And then we end our table and body. The difference with the debug that I had put out there had this JavaScript out there, and it would show you additional information for load time. You can read the article on LinkedIn to find out how I got the calculation for that. There's an additional script out here that goes out and tells you what the version of TLS was being used at the time. That's using a third-party site called howsmyssl.com, which you can check out online and figure out how to use their API. Very simple, as you can see, 4 or 5 lines of code, and we were good. I took that out after we were done debugging and just renamed this so that we were not using any of that extra load time, just so that we would not have that extra time added to it for our test results. Let's look at what Loadrunner looks like. So in VUGen, for the HTTP2 test, I recorded a single URL. We had to create a new SSL certificate afterwards, so we used a different URL than http2test.com, but it went to the same exact site, did the same exact HTML test, and I only have one transaction, which is a start and a stop. Notice we're using TLS version 1.2. When you're recording against an HTTP2 website, you're going to want to go into the recording options, and you're going to want to choose the advanced option. You'll see a listing of SSL versions available. So it is important to note the difference between just 1.2, NPN, and ALPN. As we began to test this website, Google updated the Chrome browser to version 51. And in 51, they removed all support for NPN, which was a secure negotiation that was left over from their Speedy protocol. So you'll probably see this disappear in the near future. It was replaced with ALPN. You can do a Google search and find out the difference between NPN and ALPN negotiation. It's simply one was a 3-way handshake, and the ALPN is now a 2-way handshake. So it reduced another round trip for negotiating between the client browser and the server, figuring out what it supports and what it doesn't. So after you've chosen that, you should be able to record against an HTTP2 website. When you record against it, you'll notice it looks very similar to a regular HTTP-based protocol script, But when you play it back, you will see more information about the version of HTTP2 as well as other additional headers that you may not have seen in the past. But other than that, it looks pretty much the same. There are a couple of things that we learned that I want to mention here. In that Chrome 51 update, when it removed NPN, it began to break our H2 communication to our new site. And that was because Ubuntu 14.04 has OpenSSL, a version that only supports NPN. It did not fully support ALPN. So when Google removed this from Chrome, it kind of broke it and it made all the traffic revert back to version 1.1. So in order to fix that, we had to update the OpenSSL program itself and then make some additional settings in the Nginx web server, and it began to work. What we could have also done is just started off again with an Ubuntu 16.04 version OS, which would have included the OpenSSL version that we would need. My understanding is that's probably a much easier way to go than trying to upgrade that manually. However, if you've got production servers with 14.04 or earlier, you're looking at some significant time to upgrade that. Nginx does have an article on this and some information out there now that this has actually happened. We just happened to catch it during our testing, but we did get it working. We did get it fixed again, and we saw that it was working fine. We had to use a certificate that referenced the actual website that we created and make that publicly available in order to get the H2 negotiation, the full H2 negotiation. Just going to an IP address itself would not react the same way to HTTP2. So again, I've mentioned this in the article. When you start dealing with secure connections, SSL and TLS, it does increase the complexity of the site, but I think the payoff is worth it because natively you get a secure connection and it's still faster than version 1.1. And running secure is not a bad idea for your site these days. So after we did the HTTP1 looks exactly like this, except it's just going to http1test.com with the same URL, the same timing. So for the most part, everything in here is exactly the same. So we put that into a controller test, and when I ran HTTP1 by itself, I would just uncheck the HTTP2 side. We would ramp up to 10 users over about 5 minutes, hold that time for a 5-minute interval at 10 virtual users, and then we would quickly ramp down. So if we wanted to switch over to 2, we would just uncheck that, rerun the test. We would have the same schedule. So for the most part, everything in here was the same as well. The runtime settings are exactly the same as well, and we just ran these for the period of time, so it doesn't really matter how many times we ran it. The only thing that was random about this was the pacing time. So from the time we ran that URL, we waited a few seconds before we ran it again because I just didn't want to slam the users with no type of think time in between the iteration because my purpose was not to stress test the servers or make the servers think that they were under an attack. So we turned on logging for extended logging. We just did it when an error occurred because the logs, we were pretty sure that with just that URL, we'll be able to tell if there was a problem from the errors. There's really no think time in this script. But I am going to show you as well, we unchecked defining actions and steps as transactions. And for browser emulation, something interesting here, Google Chrome. The highest version in VUGen for 12.53 is 36, and note we were using version 51, so I imagine in future versions that's going to catch up. Now, when I ran this load test, I wanted to get worst case scenario, and we unchecked simulate browser cache to get that so that we would not cache those images. We would always pull down the full 500K of data each time to get the worst case. And we can run this again with the browser cache, but what you're going to see is that initial request is going to come through, and any further request is going to be, there's going to be much different timing there. So we just felt like that was better to run in a lab situation like this. Everything else is pretty much stock in here, and we will leave it at that. I do want to mention a couple of other settings in here because, as I said, we ran into a few issues as we were testing, and we found that there needed to be, number one, for Nginx servers, we found that there was a streaming connection issue which caused VUGen to give a playback error. We contacted HP support, and they provided us with a patch. It had 2 files that needed to be overwritten. You can contact HPE support and get that patch. It will be rolled into any of the next versions if there's a server pack or whatever. It'll also be available on the website for support. I do want to mention in the options, though, in the scripting portion for replay, you need to uncheck collect replay statistics. And as you can see here, that is what displays additional information on the replay summary, that it's basically taking header information and giving you information about headers, and it's got to do some calculations. The HTTP2 headers are different than the 1.1 headers, and they have not updated the software to account for that yet. And because of that, there is another related setting in the controller, which are the web page diagnostics, and these are default on in Loadrunner. So you'll need to disable those web page diagnostics. I just disabled them here, but if you had J2EE or .NET, you could just disable them individually here. If you do not disable those in VUGen, at the end of the script, VUGen will hang because it's trying to create statistics and it doesn't have the right code to pull that header information. And the same thing is true for this. Whatever virtual users would be running and gathering that web page diagnostics information, they will hang at the end of your test and you won't be able to see it. I ended up running an individual test for version 1 and version 2 of the protocol separately. Once I did that, I created an analysis session that compared both runs that I did. They were just a couple of hours apart. So you can see they ran for about the same amount of time, a few seconds apart, same number of users. This is just my analysis session here. I am making this analysis session available on the internet. If you follow me on Twitter, my handle ID is @LoadTester, and you send me a private message, I can send you a link that you can download this analysis session and then compare and put additional graphs and charts here so that you can look at the data yourself, so manipulate it however you want. So you can see the difference in the amount of throughput that was required for 2 versus 1, the total hits, the average hits. You can also see how many passed versus version that we were using, and the average time, which is pretty significant. So you can see that the running virtual users, that profile is almost identical. The number of times that the transaction ran, which this would represent the number of URLs that ran during that period of time. This is the average transaction response time graph, and it looks very significant. I mean, it looks almost cut in half when you compare those profiles between version 1 and version 2. Very significant is the number of connections, because as we know, H2 is using a single binary connection to do all of its traffic, whereas HTTP1 can use up to 6 connections. And you can see as we ramped up to a total of 10 users, we were using 60 connections, and as we know, connections are very expensive. So we can see a lot of the differences here. I hope that this helps you understand that HTTP version 2, even with what we know already, has some exciting improvements, especially if you have a lot of small graphics on your page and you're pulling from a lot of different places and you're having to do front-end tweaks like inlining and domain sharding and things like that to reduce the timing of the rendering of the page. This is definitely going to improve that for you. As of this video, when it was made, server push and prioritization was not something that we were able to test. Server push is not being supported by the major web servers right now. And as soon as it is, then the testing products will catch up with that, and we'll be able to test that, and we'll report that to you. I feel like server push will give us an increase, as well as prioritization as well. But it's just not it's just so new of a protocol, and I think still less than 10% of all websites are still they're not on HTTP version 2, but we're going to see a huge upswing in the near term because it does improve performance. And as we know, performance is king as a differentiator. So thank you for watching my video. And if you have any questions, you can always contact me on Twitter at LoadTester or contact me through LinkedIn or other places, scottmoore.consulting. And appreciate your time and welcome any feedback that you have.